Now we will start. Now today we will discuss memory circuit. Memory circuit is basically used to store data or instruction. Hello, is there any problem?
Sir.
No, sir.
Okay. So it is used to store information or data. And in memory circuit, there are different types of memory circuit available. And depending on requirement, we have to select the memory circuit. And memory can be classified on different basis. First of all, we consider the primary or secondary and cache memory. These three different categories. Cache memory, this is basically a very high speed memory circuit which is being used in computer or any electronic system where the information processing or can perform some sequential operation is needed. In cache memory, its speed is very high, and basically in computer it is interaction with CPU.
Sir, you have muted yourself.
Sir, are you saying something?
Yes, cache memory, and it is very high speed memory. It interacts with the CPU. Basically, the things which is frequently used in CPU that can be stored in cache memory. Uh, Primarily, that CPU will interact with the cache memory, and it has some advantages and disadvantages. I have already pointed out here. Mainly, it is very fast, and it is the main memory of the computer or CPU. Less access time compared to main memory or others. Within short period of time, it can execute the information or program which can be stored in this memory, that can be executed within a very short time, and it is temporarily used. And disadvantage, it has limited capacity and very expansive. So these are the disadvantage of this memory. Then we come to the primary memory. Primary memory, basically RAM or ROM. These are the primary memory, and actually the program or information or data or result, basically it will store in RAM. So this is the primary memory. And others is the secondary memory. Secondary memory is basically a hard disk, CD drive or pen drive. That is basically either magnetic memory or optical memory. This can be used as secondary memory. So now, in case of primary memory, we can consider first read-only memory. That's mean it is ROM, and the information has been stored in the ROM, and it can be used by the computer. It cannot, it can be used or it can be read, but it cannot be write in the ROM, right? So basically the instruction or information is stored here that can use during the start, due to required to start a computer, right? So the booting system can be loaded in this memory. Then another variety, that is programmable read-only memory. So this memory is basically used to program once and then you can use it. So user can program as per requirement. Then it can be used for long time, right? So this is the programmable memory. Once it's done, you can use it. You cannot erase. So you cannot erase this program. So it is permanently, it will be stored and then it can be used. Another is EPROM. This is basically electrically erasable programmable memory. Electrically erasable programmable memory, and it can be erased by using ultraviolet light, by exposing it by ultraviolet light, and this light duration should be sufficiently large, maybe of the order of 30 to 40 minutes usually. And once you program, then you can erase it, or if you program it, then you can continue this program, because here the leakage path is already blocked. So if you store it, then it can continue a long time, maybe a few years, several years it can be used. And if you need, then it can be again erased and by expose of ultraviolet light. And another variety, that is EEPROM, that is electrically erasable and programmable read-only memory. So in this case, you can program the memory as well as erase the memory as and when required. And this programming time and erasable time is sufficiently small compared to your previous case, that is EPROM. And here this time is of the order of 4 to 10 millisecond. Within this time interval, you can program and you can also erase the content. So you can use it frequently to program it and erase it for this memory. Now another that is RAM. And you are very much familiar about this word RAM, that is random access memory. It is the primary memory of the CPU. CPU will interact with this memory through your cache memory, and it is volatile memory. Previously ROM, it was non-volatile. If you program, then it can remember it. But RAM, it is a volatile memory. So if it is data is stored in this RAM, then if you switch off the system or power cut off, then it will erase all its information. So for this purpose, to run the system, you need UPS, that is uninterrupted power supply, because if it will switch off or power off, then everything will be erased. So this RAM can be classified into two groups. One is static RAM, another is dynamic RAM. Static RAM is a low density RAM. Here basically most transistors is being used to fabricate this, and each a bit can store by considering 6 transistors in a particular unit, and 6 transistor can form a cell. That cell can store a single bit. So in case of static RAM, it consumes power continuously and its speed is high, faster speed, and this type of static RAM is basically used to design the cache memory, right? And it will consume high power, faster, used in cache memory, large size, because the chip area will be occupied by a huge number of transistors here compared to your dynamic RAM. So it is large size and it is expensive. Another is dynamic RAM. In dynamic RAM, this can be considered by using 4 transistors, MOS transistors, 4 MOS transistor. One unit can be designed, or by using single transistors. Dynamic RAM is possible. But here in dynamic memory device, basically the information is stored in parasitic capacitance. Since the information is stored in parasitic capacitance, so it is a slower device. Obviously it is a slower device compared to your static RAM. But at the same time, when the number of transistors per unit is reduced, maybe 4 or maybe 1, then it is high density. So the number of component in a small area is more. So it is high density chip. And it needs refresh continuously. It needs refresh continuously. Otherwise, due to the leakage of capacitor voltage, the high voltage or high state may goes to its low state. So data can be lost. So after a certain interval of time, it should be refreshed continuously. But it is less expensive, it consumes less power and high density, smaller in size, and this can be used as an usual RAM of a computer, right? So these are the basic things what I have mentioned. All of you know these things. For your information or background, it is pointed out here. Now we come to our main topics. So what are the basic things present in a particular memory unit? The main component of a particular memory unit or a particular memory chip is like this, that every IC or every IC chip that can be stored the data, that is the memory chip, has two common things, that is supply voltage and ground. Another thing, it has some address bus, read write signal, chip enable C signal, chip enable signal, data bus. These are the main things. And beside this, there are some interruption, external interruption is also there. And it can be used in different modes, serial mode data input or parallel. That will depends on different interrupts. So the essential component, that is address bus. So this address bus basically identify a particular memory location where you want to write the data or from where user want to retrieve the data. So address is an essential component to identify a particular memory location for reading purpose or for writing purpose. Now, this address bus is connected to a decoder, and this decoder decode that address line and point out the location in the memory state. Now, the decoder has two types. One is row decoder, another is column decoder. Row decoder select a particular row on which user want to read or write the data, and column decoder is a particular, and column decoder will detect a particular column on which user want to read or write. So now, by exciting a particular row and a particular column, there will be a single element is common in that row and column. So that particular element is responsible for reading and writing. Point is clear. So the address bus is connected with decoder, and there are two types of decoder. One is row decoder, another is column decoder. So row decoder will determine that particular row, and column decoder will determine that particular column, and the common element of that row and column is responsible for retrieving the data or for writing the data. Point is clear. Now we come to read write bar signal. Read write bar signal is connected to read write bar and sense amplifier. Read write bar and sense amplifier, actually it will sense, it will determine whether user want to read the data from the memory location or user want to write something on the memory location. Memory location means which is already specified by address line or address bar, right? So if it is read, then your signal will be high. This read write bar signal will be high to read the data from the memory location, and it is low when user want to write something on the memory location, that is write bar. So it is active in write bar, that's mean 0 when signal is low, that is 0, and read will be active when it will 1, that is high. So the read write and sense amplifier will sense whether user want to read or write, and accordingly it will perform the operation. Another type of signal, that is C signal, that is chip enable signal. If you want to expand the memory, then which IC or which chip will be enabled to reading or writing? At a time, all the chip will not be enabled to reading or writing. So which chip will be responsible for reading or writing the information, that can be determined by chip enable signal. Next is data bus. So data bus, through which the data can enter into the memory or data can retrieve from the memory. So data bus is connected to a buffer. So buffer is also connected in the sense read write and sense amplifier. So initially data, if you want to write something, then data will comes to the buffer. Then after identifying that the particular location, sense amplifier will shift this data from buffer to that particular memory location. Or at the same time, sense amplifier for reading purpose, sense amplifier will determine that particular memory location, and data from that location will transfer to the buffer, and data bus will responsible for transferring the data to a particular output or for processing, right? So data bus is bidirectional. This data bus is bidirectional. It can be used for writing or reading. But you see, address bus is unidirectional. Address bus is unidirectional. It will determine the particular location in the memory state. So it is unidirectional. Right. So these are the basic components present in the memory circuit. Now we consider expansion of memory. For example, we consider we need to design 4K into 8 memory using 1K into 8. 1K into 8 means it has 8-bit data. The data length is 8-bit and it will specify 1K different location. It is 1K different location, and each location can contain the 8-bit data. So that is why it is called 1K into 8 memory. Now our purpose is, in some particular application, we need more memory. We need expansion of memory. So we need 4K into 8 memory. So different location will be 4K and the bit length will be 8-bit. So to produce 4K memory, we need at least the commercially available IC 1K into 8 4 number. So we need 4 IC to expand the memory to 4K into 8. And when we get 4 different IC, each IC can contain 1K memory location, that is 1024. So 4K that will produce 4096 different memory location. To identify this 4096 different memory location, you need 12 address line. You need 12 address line because 2 to the power 12 equal to 4096, right? So therefore, so out of this 12 address line, 10 address line will be common in all the IC, because here we have used 4 IC. So 10 address line will be common for all the IC, all the 4 IC, and 2 address line, and the highest order 2 address line will be used as chip enable signal, and the next 2 address line will be used as chip enable signal, and that chip enable signal can be determined with the help of 2 to 4 decoder. This chip enable signal can be determined with the help of 2 to 4 decoder. At a particular instant of time, these 2 address line in the decoder will activate a particular output out of its 4 output. So which output is active, that particular chip will be responsible for reading or writing the information. You see, in this figure, it is mentioned, this is the address bus, 12 address bus, out of which 0 to 9, these are common in all the 4 IC. And 10 and 11 are connected to a decoder. Then when these 2 address line both are 0, then it will activate this first IC. When 10 is 1 and 11 is 0, then it will activate the second. Then when 11 is 1 and 10 is 0, then it will activate the third one. When both are 1, then it will activate the fourth one. That means depending on this address, these two address line, it will determine a particular IC in active mode. Then that particular IC can be used for reading or writing. Now, whether user want to read or write, that is determined by read-write bar signal. If this signal is 1, that is high, then it understand that user want to read something from that particular memory location. And if it is 0, then it understand that user want to write something on that particular memory location. And what it will do, that data is present in the database through the buffer. So the data can store in the buffer for writing purpose or for reading purpose. The data will shifted to the buffer through the sense amplifier, then it can be used for processing or for output. So these are the configuration for connecting the different 4 IC to expand the memory 4K into 8. Point is clear?
Yes, sir.
Now we come to another memory expansion. This is 4K into 16 memory using 1K into 8. Now we want to expand the memory 4K into 16. Previously it is 4K different location, but bit length was same as previous, that is 8 bit. But now we need 16 bit memory. So each location can contain 16 bit. So how we will produce 16 bit memory location? So 16 bit, to produce the 16 bit location, then you need how many IC? That you need 8 different IC. Because to produce 4K, you need 4 IC. Then each IC will contain 8 bit. So 2 IC you need to use to contain 16 bit. Right? So 2 IC can be connected in parallel, so that one IC will give you lower order data and another IC will gives you higher order data. That is starting from your LSB to 8 bit, and other one will give you that 9th bit to MSB, right? That we have to collect from the other IC. So 2 IC are connected in parallel, then we will get 16 bit. So the configuration or connection will be almost same to the previous case, but in this situation, we have to use 2 parallel IC for calculating or for getting the lower order data and higher order data. If you compare in previous figure, then you see all are same, but here the data is connected in this IC, that is D8 to D15, and here it is connected D0 to D7. So lower order data we are getting from this one, and higher order data we are getting from this. So these two IC are connected in parallel. You see, this is A0 to A9 is common for both the IC. At the same time, chip enable signal is common for both the IC. So that means these two IC will activate simultaneously. Then it will
Sir,
give
could you
you the
repeat the
data
data
length.
bus thing, sir?
Okay. This one or previous one?
Sir, this one, sir.
Okay. So now here our aim is to expand the data, that is 16 bit, and our available memory is 8 bit. That means each IC a particular location can contain 8 bit data, but we need 16 bit data. then we have to consider two IC in parallel connection. One IC will give you 8-bit data, another IC will give you the another 8-bit data. So for our convention, we consider this IC will gives you the lower order data bit, and this IC will give you the higher order data bit. Then these two ICs should be connected in parallel so that both of them will activate simultaneously. Now, for addressing, because it is 4K, so 12 address line is needed. So 10 address line is common for all the chip is different for different pair of this IC. This pair chip enable signal will be active when 00. This input will be 00. Then it is high. This pair will be active when this address line 10 and 11 will be 01, and so on. So suppose when this chip enable signal is high, that's mean your input is 00. So decoder output, this output will be high. So then these two IC will be active. So when it will be active, then data, if we consider read, then that particular memory location of this IC and this IC will be identified. Then the data in this particular memory location and in this memory location will come through buffer to this address line for further processing or output. But we have already determined that this data is the lower order data, that is D0 to D7, and the data coming from this IC is the higher order data. So when we write the data or write this data in this IC, we will put higher order data in this IC and lower order data in this IC, because these two are connected parallel. So 8-bit, then next 8-bit. Like this way, we have considered the data. Right? We have shared the data in two different IC, then we can expand it 8-bit data. Right? And the other operation will be almost similar. So all the lower order data will be getting from this IC. Out of this pair, lower order data is coming from this IC, higher order data is coming from this IC. Right? Then like this way, we have to connected the data. Now at present in computer system, you are running with 32-bit or 64-bit or 128-bit data. So if it is 64-bit data, then you can expand by this memory like this way. That is by considering the parallel combination. This is 16, then 4 or 8 different IC can be considered to make it parallel combination to get the data. Right? So like this way, you can access the, or you can increase the data length you can increase. Okay. But commercially, it can also available 16-bit or 32-bit IC. 16-bit and 32-bit data length IC is also commercially available. So that can be used to expand the can be used, or that IC can also be used to expand the bit length of particular applications. Point is clear? Now, next you want to see how the memory is organized inside this IC. How the memory is organized inside this IC, that we need to investigate. So here, previously I have mentioned that data is arranged in two-dimensional mode, that is row addressing and column addressing. So this address line is divided into row address line and column address line. It is passes through row decoder and column decoder. Then the output of the row decoder and column decoder are connected to the memory state. So how it is organized? For a particular memory, we consider here. For particular IC, this particular IC, what is present, internal things that we are presenting here. Now, this is the two-dimensional addressing of this memory that I have already mentioned, that this address line one is row decoder, another is column decoder. Now you see it is 1K into 8-bit memory. That is, this is the first bit, second bit, and this is the last bit, 16-bit, right? That we have arranged. Oh, sorry. It is 1K into 16-bit memory. 1K into 16-bit memory organization. So it has 10 address line. That is 1K different location. 1K different row it is considered, and here that is Y0 to Y15, that is 16 bit. Each location can contain 16 bit. How it is organized? So here address line is A0 to A9, that is 10 address line is used to identify 1K different row. It is starting from X0 to X1023, right? And here you see this decoder, column decoder, has contained A0 to A3, that is 4 bit. So 4 to 16 decoder. So at a time one will be activated, that is Y0 to Y15, that is 16 bit memory. Now this particular row will be selected by a particular instant of time by highlighting this. Suppose all are 0, then X0 will be high. If A0 is 1, all others are 0, then X1 will be high. So this row will be activated, right? Similarly, if Y0 is 1 high, then this particular column will be active. If Y1 is high, then this column will be active, right? So by selecting a particular row and a particular column, you see a particular element is active. So that particular element, you can read the data, what is present there in that particular element, or you can write information in that particular element, right? So this is the two-dimensional addressing. Here you see this column decoder is connected to the common base of two NMOS transistors. These two NMOS transistors, this transistors is connected to 0-bit line of this first column, and this one is connected to the 1-bit line of the first column. So 0-bit line is connected to read-write 0 amplifier, and 1-bit line is connected to read-write 1 amplifier. So for all the columns there are two lines. One is 0-bit line, another is 1-bit line. And 0-bit line is connected to read-write 0 amplifier, and 1-bit line is connected to read-write 1 amplifier. Because this 0 amplifier and 1 amplifier is responsible for reading 0 or writing 0, and 1-bit line and read-write 1 amplifier is responsible for reading 1 or writing 1 in that particular cell. So to access a particular cell, you need to first address to that particular cell by selecting your row decoder and column decoder. Then you can retrieve or write the information in that particular cell. So when you want to change all the bits, then selectively you have to select one by one all these element by considering row and column. Then you have to read and write. Like this process, we can access or we can write the information in the two-dimensional addressing memory location. Point is clear? So today we will stop it here. In next class, we will complete this portion. So this is known as two-dimensional addressing. Now, what things is present in a particular location? What are the circuit component present here in a particular element that we will consider in next class, right? In case of static RAM or in dynamic RAM, that we will discuss in next class. Point is clear?
Hello, sir.
Yes.
Hello, sir.
Yes.
Sir.
Sir, I want to ask a question.
Yes. You ask.
Sir, what is the basic reason behind RAM being expensive than ROM?
Actually, RAM, that is, it is random access. So you can access any location with the same time interval. And this RAM actually, basically, in case of ROM, it is being used for cache memory. So if you want to purchase this cache memory, it is costly. It is costly compared to your RAM, which is already inbuilt in your motherboard. Or you can purchase it externally, you can add it. And compared to ROM, RAM is more expensive if you consider at present day technology that dynamic RAM, which has a specific frequency value, refreshing and high density. So due to this high density and it is low consumption of power, it can, the technology that being used to design that, it make it more costly. The design technology, that is low power consumption, high density, that makes it expensive. In case of single transistors dynamic RAM, it is costly compared to a ROM. But the specific ROM, when it is being used for your cache memory, that is relatively more costly compared to your RAM. But in general, RAM is costly, dynamic RAM, compared to your ROM.
Okay, sir.
Sir, I had a quick doubt, sir. Sir, in the two-dimensional memory division, like allocation that you saw, 4 to 16 is the column decoder and 10 to 1024 is the row decoder, right?
Yes.
Okay.
According to our this configuration.
Yes, sir.
According
Yes,
to
sir.
this configuration. Because
Yes,
we
sir.
have considered a memory IC which has 1K into 16 bit. If we consider 4K into 32 bit, then in the row decoder will be 4K, that is 4096, and
Yes,
column
sir.
decoder will be 32 bit, means it will be 6 data will be there, right?
Yes, sir.
So depending on that, which type of
Yes, sir.
IC and how the two-dimensional addressing is present in that IC, depending on that row and column decoder we have to consider.
So that is a 1K and this one is like a 4. Acha.
Okay, this is 1K 16-bit memory.
Yes, sir.
In a particular IC, 1K 16-bit, then its addressing or organization of the unit is like this.
Yes, sir. Got it, sir.
Okay.
Sir, will you upload the notes of this today only or after the next class?
I think today I will upload.
Okay, sir. Thank you, sir.
Thank you, sir.
Okay. Okay, so next class we try to finish it.
Okay, sir.